The volume of the cuboid. Booklet page 57. The solid, any object that occupies a room in the space. The volume, it's the number of units which a solid consists of. The cubic centimeter, it's the volume of cube of edge length that's equal 1 centimeter. So I have here 1 times 1 times 1, it's equal to 1 centimeter times 1 centimeter times 1 centimeter equal to 1 centimeter cube. In the opposite figure, represent the number of cubes which the edge length of each is 1 centimeter. So I will count how many cubes here I have in each shape, or in each figure. Let's count together. I have here 1, 2, 3, 4, 5, 6, 7, 8, 9. So the volume here is 9 centimeter cube. Here I have 1, 2, 3, 4, 5, 6, 7. So the volume here is 7 centimeter cube. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The volume is 10 centimeter cube. Here the volume is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 centimeter cube. Here the volume is 1, 2, 3, 4, 5, 6, and I have here hidden 7, 8, 9. So it's 9 centimeter cube. Here the volume is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The volume is 18 centimeter cube. Booklet page 58. Let's remember together the perimeter of the rectangle is length plus width times 2. The area of the rectangle is length times width. The perimeter of the square is side times 4. And the area of the square is equal to side times itself, which is equal to side times side. Very important rules. The volume of the cuboid. If I have a cuboid and I want to get its volume, the volume will be equal to length times width times height. So the volume of the cuboid, length times width times height. L times W times H. This is the length, this is the width, and this is the height of the cuboid. The volume of the cuboid equal length times width times height. This is the first rule. And this is our magic triangle. So to get the volume of the cuboid, it's equal to length times width times height. To get the volume, hide the volume, it's equal to length times width times height. And we have another rule for the volume of the cuboid. The first rule is length times width times height. We have another rule which is the volume of the cuboid equal base area times height. Base area times height. So if I want the volume, I will hide it and it will be equal base area times height. What if I want the base area? I will hide the base area in the magic triangle, and what's left in our magic triangle? Volume over height. So the base area equal volume over height. Here in our magic triangle of volume equal length times width times height. If I want to find the height, I will hide the height. What's left in our triangle? Volume over length times width. So to get the height, it will be equal volume over length times width. If I want to get the length, I will hide the length. What's left in our triangle? I have volume over width times height. So to get the length, it will be equal volume over width times height. What if I want to get the width? Hide the width. What's left? Volume over length times height. So the width equal volume over length times height. The cuboid has 6 faces, 12 edges, and 8 vertices. Each two opposite faces in the cuboid are equal in area. Booklet page 59. Number 1 completes the volume of the cuboid. We have two rules for the volume of the cuboid. The first one, here if I have 3 spaces, it will be length times width times height. And the second rule, if I have only 2 spaces, it's equal to base area times height. Letter B. A cuboid has the dimensions 20 centimeter, 5 centimeter, and 14 centimeter. Its volume equal. To get the volume of the cuboid, I have to write the rule. The rule of the volume of the cuboid is equal to length times width times height. To get the volume, I will multiply the length, which is 20, times the width, which is 5, times the height, which is 14. 20 times 5 times 14 equal 1,400 centimeter cube. Number 2. Which is greater in volume? A cuboid of dimensions 24 centimeter, this is the length, 8 centimeter, this is the width, and 16 centimeter, this is the height, or another cuboid of base area 72 centimeters squared and height 42 centimeters. So I have here 2 cuboids and I want to compare between their volumes. So I will get the volume of the first cuboid. It's equal to length times width times height. Length times width times height is equal to 24 times 8 times 16, equal 3072 centimeter cube. The second cuboid, to get its volume, I have here base area and height, so I will use the rule of the base area times height. Volume equal base area times height equal 72 times 42. 72 times 42 equals 3024 centimeter cube. So the volume of the first cube is greater. Number 3. A quantity of sugar fills a cuboid-shaped box of dimensions 21 centimeter, this is the length, 19 centimeter, this is the width, and 12 centimeter, this is the height. Can we put the same quantity of sugar in another cuboid of dimensions 24 centimeter, this is the length, 14 centimeter width, and 13 centimeter height? Why or why not? Let's see. I have to get first the volume of the first cuboid. The volume of the first cuboid equal length times width times height equal 21 times 19 times 12 equal 4,788 centimeter cube. And I have to get the volume of the second cuboid. The volume of the second cuboid equal length times width times height equal 24 times 14 times 13 equal 4,368. So the first cuboid is bigger. So I can't put the same amount of sugar in a smaller cuboid. So I can't do it because the second cuboid is smaller than the first one. In number 4, a cuboid box had the dimensions 20 centimeter, 1/5 meter, and 70 centimeter. Find its volume in centimeter cube. So I have here the dimensions 20 centimeter, this is the length, 1/5 meter, this is the width, and 70 centimeter, this is the height. You have to realize here that the length and the height are in centimeters, but the width is in meters. So I have to change the meter into centimeter. To change from meter to centimeter, I have to multiply by 100. So 1/5 meter times 100 equal 20 centimeters. So I can now get the volume of the cuboid, which is equal length times width times height, equal 20 times 20. Now the width is equal 20 after converting it into centimeter times 7 equal 28,000 centimeter cube. Booklet page 60. Number 5. A cuboid box of dimensions 60 centimeter, this is the length, 24 centimeter, this is the width, and 10 centimeter, this is the height. It's needed to be filled with cuboid-shaped bars of soap of dimensions 12 centimeter, 5 centimeter, this is the width, and 3 centimeter height. Find the number of bars of soap needed. So I have here a big cuboid and I want to fill it with a smaller cuboid. So I have to get the volume of the big cuboid and the volume of the smaller cuboid, and then I have to find the number of the bars of soap. So first I have to get the volume of the box or the big cuboid that I have. It's equal to length times width times height. So it's equal 60 times 24 times 10, equal to 14,400 centimeter cube. And then I will get the volume of the bar of the soap. It's equal also to length times width times height. So it's equal 12 times 5 times 3 equals 180 centimeter cube. So now I want to get the number of the bars of soap that can be filled the box. I have to do what? To get the number, I have to make the big volume over the smaller volume. This is the rule. So the big volume here of the box is 14,400 over the small volume, or the volume of the bars of soap with the small volume, it's equal to 180 centimeter cube. So 14,400 over 180 equal 80 bars of soap. In number 6, I have a juice case in the shape of cuboids. Its base is square shaped of side length 5 centimeter and its height is 10 centimeter. Calculate the volume of juice which filled the case completely. So here I have a very important note that the base is a square shaped. So to get the volume of the cuboid, I have here the side length of the square is equal to 5 centimeter. This is the side. And the height is equal to 10 centimeter. To get the volume of the cuboid with square base, it will be equal side times height. Why? I didn't do it length times width because here I have a square base. So the area of the square is equal to side times side. So it's side times height, not length times width. So side times height. So it's equal 5 times 5 times 10 equal to 150 centimeter cube. Number 7, a truck for transporting goods. Its dimensions are 3 and 1.5 and 2 meter. This is the length and the width and the height. And here they are in meters. It wanted to fill it with cartoon boxes for mineral water bottles to distribute it to the commercial shops. The dimensions of the cartoon box are 40 and 25 and 25 centimeters. So the length 40, the width 25, and the height 25 centimeters. I want to calculate the greatest number of cartoon box can be carried by the truck. So to get the number, I have to get the big volume over the small volume. So first I have to get the volume of the truck and then the volume of the cartoon box and make big volume over small volume. But here I have the dimensions of the truck is in meters and the dimensions of the cartoon box are in centimeter. So I have first to change the meter to centimeter. So the length of the truck will be equal 3 meters times 100 equal 300 centimeters. And the width 1.5 meter times 100 equal 150 centimeters. And the height equal 2 meter times 100 equal 200 centimeters. So when I have different units, I have to change or to convert the meter into centimeter. So now my new dimensions are the length 300 centimeter, the width 150 centimeter, and the height 200 centimeter. The volume of the truck equal length times width times height. So the volume equal 300 times 150 times 200 equal 9 million centimeter cube. And then I have to get the volume of the cartoon box. It's equal to length times width times height. which is 40 times 25 times 25. These are the dimensions of the cartoon box, equals 25,000 centimeter cube. To get the number, I have to make the big volume over the small volume. So the big volume, 9 million over 25,000, equals 360 cartoon box. So I got the number of cartoon box. Then he wants to know the cost of transportation if the cost of transporting one cartoon is 0.75 pounds. To get the cost, I will multiply the number of the cartoon box by the cost of one cartoon. So I will multiply 360 times 0.75 equal 270 LE. This is the cost.